Welcome everyone. Today's video is on squares and square roots. So title your notes. And the first thing we'll look at is area of a square. So remember, to find the area of a square, you multiply the side times the side, which we could write as side squared. So if we look at this example here of this square, I know it's a square because there's 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5 squares on each side, so it's the same length on each side. So in order to find the area of it, I would multiply 5 times 5, which is the same as 5 squared, and that equals 25. Now notice I put units squared because first of all it's units because I don't know if it's being measured with centimeters or inches or any other type of unit, and it's squared because we're talking about area. Now if you were to count up every square inside of here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if you kept going, there would be 25. What that's saying is you have 25 of each of these little squares within this big square. Okay, now what that was, what we were just working with, is called a perfect square. So the definition of a perfect square is, it says a number is a perfect square if you can take that many 1 by 1 unit squares and form them into a square. So it can't just be anything. Let me show you what I mean here. If I took one single unit square, this is a 1 by 1 unit square. That's obviously forming a square, so that could be my first perfect square. So 1 is a perfect square. Now let's try doing 2. Will 2 work? Can we take 2 unit squares and form them into a square? No, we cannot, because this is a rectangle, because along this edge it's 2 units long and along this edge it's 1. So that doesn't fit the definition of a square, so I need to keep going. Can it be 3? Obviously not. That's not a square. So therefore 4 would be my next perfect square because I had to take 4 of these unit squares to make a square. I could keep going and add more. That would be 3 along that edge. It's not lining up perfectly, but you can see what I mean here. So I'll keep adding because again it needs to form a square. So now I've used 9 unit squares, so 9 would be my next perfect square. Now that we've established squares, let's talk about square roots. That's the symbol for square root, and it looks like a check mark with a line above it, and then you would see the number underneath here. So that would be the square root of 9. When a number is a perfect square, the side length of the square it forms is called its square root. Let's look at an example of this. We've already established that this square here has 25 square units. That was the first example we did, and it is a perfect square. So in order to get the square root, we need to figure out the side length, the length of one of the sides. So here I have 1, 2, 3, 4, 5. I counted this one, but it didn't write. So it's 5, so that means that the square root is 5 units. Notice I'm putting the units because we are talking about a square, but what you could say is that the square root of 25 equals 5. So basically the square root of a number is just the inverse of the square. It's undoing when you square the number. So here's what I mean. If you take the number 1 and you square it, so what I'm doing is 1 squared. Okay? And remember that 1 squared is equal to 1 times 1. So that would simply be 1. Now if I take the square root of 1, I'm just filling this number in here, I'm undoing what I just did, so the square root of 1 would be 1. Now 1's always hard to see because they're all just 1, so let's take a look at 2. If I take 2 and I square it, 2 squared means 2 times itself 2 times, so 2 times 2 would be 4. Now I want this number, so the square root of 4. Well, the square root of 4 is just undoing what you just did, so it would be back to that original number, which is 2. And then I'll keep going. Let me erase these so you don't get confused. But I have 3. I want to take 3 squared, which is 3 times itself 2 times. So 3 times 3 is 9. And now the square root of 9, undo that, would just be back to the 3. Think in your head, what times itself equals 9? Well, 3 times itself. 3 times 3 is 9. And for the last example, 4 squared, 4 times 4 is 16. The square root of 16 would then be 4. Okay, now I took that same chart and here's what we've already filled in. But I have to take it a step further because we're actually not done. Most people just stop and say, well, the square root of 1 is 1 and the square root of 4 is 2. But there's actually 2 answers for all of these. So I'm going to put a comma here because we have 2 answers for each one, so I've got to add on. When we were talking about the square root of 1, we were thinking in our heads, what times itself equals 1? So we've already said, well, 1 times itself. 1 times 1 equals 1. But we could also say that negative 1 times itself, so negative 1 times negative 1, would also equal a positive 1 because a negative times a negative is a positive. Okay, see that now? So here we asked what times itself equals 4. Well, 2 times itself, 2 times 2 equals 4. But we could also say negative 2 times itself equals positive 4. So I'd have to add a negative 2 in here. And as you can see, this will work for all of them because negative 3 times negative 3 would be a positive 9, and negative 4 times negative 4 would be a positive 16. So you actually have to have both of those answers to be correct. And now in our last example, we're looking at the square roots of fractions. So we have the square root of 4/9. And I know this looks intimidating, but watch how simple it is. When you have the square root of a fraction, you're simply taking the square root of the numerator and the square root of the denominator. So let's just look at the top number, the square root of 4. The square root of 4 would be 2 because 2 times itself, 2 times 2 is equal to 4. And then the square root of 9, well, that would be 3 because 3 times 3 equals 9. And remember, we're going to have 2 answers for this, so we'll also say a negative 2/3 because a positive 2/3 times a positive 2/3 equals 4/9. And a negative 2/3 times negative 2/3 equals 4/9. And then down here in this example, the square root of the numerator, which is 25, would be 5. And the square root of the denominator, which is 81, would be 9, but I also have to say negative 5/9. And since neither of these can be simplified, that's all I have to do. So for this last one, why don't you pause the video, try this yourself, and make sure you have both answers, and then you can play the video to correct your work. Okay, so here we have the square root of 16 over 100. So the square root of 16 would be 4 because 4 times 4 equals 16. And the square root of 100 would be 10 because 10 times 10 equals 100. But I have to be careful here because this can be simplified. Both of these are divisible by 2. So 4 divided by 2 would be 2, and 10 divided by 2 would be 5. So your final answer actually should have been 2/5 or negative 2/5. And for the bottom here, the square root of 36 is 6, and the square root of 49 is 7. That cannot be simplified, so my answer is 6/7 and negative 6/7. That's all for squares and square roots. Bye, guys.